So I'm going to put together a little tutorial for you guys. The exam is tomorrow, and hopefully this might help you. This is probably the one topic that I don't know if I want to say concerned and scare you, but this was a fairly brief topic that we did, and it is important, and that is centroids, finding centroids of like complex shapes, as in shapes that are made up of more than one thing, composite shapes. And you won't have spreadsheets in the exam, so I just want to show you what that looks like without spreadsheets. We did assign reading from the textbook. If you want that, I do advise that. That was on, I'm looking up right now, let's see, page, all right, so on page 137 is a good place to start, and then I'd say going through to page 141. Okay, that tells you everything you know, and of course he's doing it without any spreadsheets at all, so it's very, very doable. So the first thing we want to do, step one, is break up the shape into its constituent bits and pieces. Now this includes both positive and negative area. And by the way, let me give you a little whisper here. This is going to be a more complex example than in the exam. So I don't want this to freak you out. I want to overly prepare you so you're very ready. So with this shape here, I am going to think to myself, what's the least complex way that I can put this shape together, the least number of pieces. I have like a kind of a block with a chip off the side, chip off the old block. I've got a circle in it, a cutout. Here's what I'm going to say. I'm going to say shape 1 can be a 5 by 5 square. I'm going to say shape 2 is actually like a negative triangle cutout. I'm going to think of that as a cutout. And then shape 3 for me is going to be the circle. All right. Now this is a little unusual because we're doing two negative shapes, two negative empty shapes. Other ways to do this, I could have had, here I'll do it and then I'll erase it. I could have had a rectangle like that, another rectangle, a positive triangle, and then a circular cutout. That would have worked just fine, but I'm going with this square, this cutout, and then this circle. All right, hope that makes sense. Let's go into it. So the second thing you can do after you have labeled those different things is, I'm going to say, all right, let's set up an axis system. The axis is just going to be a very convenient reference point to measure everything from in terms of X and Y with an origin. Okay, that was quick, that was easy. Bottom left is often a really good place to do it. Otherwise, if there are axes of symmetry, that's also a good way to do it. Next is we want to think about the areas. And so I start to make a table at this point. And my table is going to have shape 1, 2, and 3. And my table is going to have areas. And I'm just going to sort of quickly do these. They're pretty straightforward. So the big one here is simply a 5 by 5 square. It doesn't take a lot of thought to see the area here measured in meters squared is 25. Oh, rats. Hold on. I really want to get rid of that green circle before I do anything else. Okay, got to click undo. All right. Shape 2 is my little cutout triangle. That is 2 times 2, but then it's half base times height. That's triangle area. So 2 times 2 is 4. Take half of that. We have an area of 2. And then the circle's area, area of a circle is pi times radius squared. We have a radius of 1. So I'm going to use 2 decimal places. 3.14 is the area of that circle. So already I actually have some kind of helpful information here. I can total up those areas, but now, oops, I see something I did actually forget to do. these are negative areas. These are minus signs, okay? So when I total up my area, it's 25 minus 2 minus the 3.14. I have a total area of 19.86 square meters. And that in itself is actually pretty valuable information. 19.86, less than the full 25 for sure because of those cutouts, those negative areas. Okay, now I've done the areas. Let's take care of the individual centroids. So I'm going to list X and Y. I'm going to talk about them as coordinates. For the big square, squares are really easy. The centroid for that is just dead in the middle, where I just put that green dot just then. So its coordinates are 2.5 and 2.5. I might jump to the circle because the circle here is actually easier as well. The circle's centroid, its personal little individual centroid, is 2 and 2, which is actually pretty close. The one that's always a little itty bitty bit trickier is the triangle. Remember, the triangle is in 1/3 of the way in from the thick end in both directions. Okay, 1/3 of whatever its base is across from the thick end, 1/3 of whatever its height is from the thick end. We have talked about this at length, so that's all I'll say. Just keep this video as short as I can. I'll see if I can get under 10 minutes. I'm not quite sure. All right, so that, let's get rid of all that green. Boom, boom. Okay, so that, if you will bear with me, is going to be, let's see, 1, 2, 3, 4 and 1/3. That's going to be 4 1/3 across from the origin. And actually it's going to be the exact same other way as well. 4 1/3 up. Okay, so again, if that point is right here, we're talking 4 1/3 across. It's the 3 plus the 1 1/3, and then also 4 1/3 up. That's where those two numbers are coming from. If you don't get that, you should probably go back and watch more videos or ask me some questions, but I think I will keep going. Now what we need to do is we need to use the formula. I'm just going to use the kind of quicker version of it here, without the I's and the 1's and the N's and things like that. It works the same for both. All right. We are summing up the products of the X centroids and their areas and dividing by the total areas. So how does that work? Well, for the first one, what we're really saying is X bar equals 2.5 times the area plus 4 1/3 times minus 2 plus 2 times negative 3.14. And then we're dividing by the total area. I'm just going to use that number 19.86 because we already had that worked out. So why not just use that? And pardon me while I get the old calculator out. Notice while I'm doing it, those negative areas, they do show up again. Very important. All right, so that leaves me with, oops, that leaves me with 47.553 repeating over 19.86. I divide that, and I get 2, let's just say 2.4. Two significant figures there, 2.4 meters. And so that 2.4 meters, that is, let's see, that is somewhere, it's a little It's a little less than 2.5. Okay, this is the 2.4 I'm looking at right here. Little less than the 2.5. The 2.5, by the way, remember, was the center of the untouched square. Before we chipped the edge off it, before we drilled that big hole in it, it was at exactly 2.5. So having 2.4, I think it makes sense to me. It's very close, as I'd expect it to be. The triangle and the circle affected it somewhat, but not ridiculously. Okay, and then I am going to go down and do the Y centroid as well. And exactly the same process. We have 2.5, this is the Y coordinate this time, times 25, plus 4 1/3, again, happens to be the same number, but I'm getting the Y coordinate. Actually, they're all the same. How did I manage that? That is a complete and utter accident. Maybe not the best example. And then also divided by 19.86. So that also gives me 2.4. I didn't see that one coming. I should have seen that, guys. And actually, as I think about it though, here's why it makes sense. Okay, so this right here. This is the overall centroid at 2.4 across, 2.4 up. That makes sense because if you were to somehow rotate this page and you spot the fact that, hey, look at this. There's an axis of symmetry right there. You can rotate your computer screen or your laptop if you want to make that vertical. This is like a perfect butterfly, you know, like a Rorschach butterfly picture. And so remember that whenever there's an axis of symmetry, you've always got the CG, sorry, you always have the centroid right on that axis of symmetry. So it is kind of like a symmetric diamond. It's almost like a diamond with a hole in it. So of course, we end up with an identical XY coordinate pair for the centroid. It must be so. So like I say, this is more complex than will be on the exam. This has negative area. This has 3 shapes, although it could have been done with 4 shapes, 3 positive and 1 negative hole. A hole will always be in negative shape, but little chip-offs you can choose. But the process is totally identical, and I didn't need a spreadsheet, okay? The really important thing is that you have these formulas ready to go, and then that you know how to then convert those into a list of multiplied x coordinates times areas and y coordinates times areas. And just to be clear, I used the y coordinates here and I used the x coordinates here. The areas in purple, the areas get used in both equations. Okay, those are always just the same. That's just the area. That's x times y. But you use first the x coordinates and then the y coordinates when doing this. All right, I think that is everything. I guess step 5 there was I'm going to call it the weighted average. That is the best way to refer to that. It's exactly the same as a grade book with a strongly weighted test or final exam category, and then discussion board categories, and then assignment categories. We weight them differently, and so they all pull the average more towards themselves or not than other things. All right, I hope this was helpful. We did it in 14 minutes. Have a good night studying.